Hello, my name is Alexander and I'm going to tell you about artificial intelligence and machine learning in simple words. If you're interested, let's get started. When I ask what you think artificial intelligence is, many people answer it's kind of a robot like a Terminator, capable of performing many actions and able to seize power over humanity. But before we go further into this concept, let's try to answer a few questions. Who is shown in this picture? And who is this? Can we distinguish between breeds? Who are they? What is special about this picture? And who is it? Can we say what it is? And what kind of animal is this? Can you guess? Can we understand what is written here? Try to read. And how would a 5-year-old child respond? I asked the same questions to my 5-year-old son, and this is what he answered. Here he replied that it's a cat lying behind a sofa. It's quite obvious. These are cats, of course, but he doesn't know the breed. One of us can probably distinguish some of the breeds shown, isn't it? Here he said that he sees a cat and he doesn't know other animals. Oh, it's interesting. Here he replied that it's a monkey. This is quite good because he doesn't know who the sloth is, and this is sloth. But he saw a monkey hanging on a tree many times, for example in the picture, on TV or at the zoo. What about this? Here he said it is an orange, but in fact it's a clementine, a mixture of orange and tangerine. Oh, it's interesting. Here he suggested that it is a rabbit. In fact, this is a very rare animal called the illy pig. It's very rare. He lives somewhere in the Himalayas, if I'm not mistaken. He cannot read yet, so he could not read this text, but we can do it, right? Of course. What conclusion can we draw? We will identify objects that we have seen many times. Our own neural networks have been trained on many samples. And those objects that we rarely saw or didn't see at all, we can hardly recognize, or we can make some assumptions. If we compare the specialist and artificial intelligence, then here is what we can see. The specialist studied at the university, for example, received knowledge on additional courses, gained work experience, etc. He or she subjectively perceives the question, and if he knows the answer, he answers. If he doesn't know, then he can discuss. So, what about AI? It's trained on using big data and it uses neural network for training. If you ask question, it analyzes the sound or text or image. If it knows the answer, it answers. If it doesn't know, it needs additional training on relevant data. A little bit about data. Data is everywhere. The term big data, you probably heard this word before. The term big data is understood to mean any data sets that are large enough and complex though they cannot be processed by traditional computer. There is no consensus on how much to consider big enough, but remember that the term big data is not just about the amount of data. And the term 5V, volume, velocity, variety, veracity, and value, is associated with big data. This is the volume of information, volume, the speed of its processing, velocity. It's the variety of information stored in the data, variety. It's the reliability of this data, veracity, as well as their value. So it should be useful and necessary in terms of value. So we can say that big data is the fuel for artificial intelligence, which includes machine learning, deep learning, and many other approaches. Speaking about artificial intelligence, we will primarily mean machine learning and deep learning with neural networks, which are the most popular subfields of artificial intelligence present. But it's worth noting that there are many other methods. So on this slide you can see the definitions of artificial intelligence, machine learning, and deep learning. There are several areas in artificial intelligence, the most popular of which are data science, computer vision, natural language processing, and machine hearing. In data science we include advanced statistics, predictive analytics, data visualization, interpretation, and communication. In computer vision we work with video or images. In natural language processing we work with texts in natural language. In machine hearing we work with sound or voice. AI also divided into strong and weak artificial intelligence. Weak or narrow AI is what we have now. It solves a single task or a limited type of tasks. Strong AI or general AI, also known as artificial general intelligence, has human-like abilities. It can solve a complex of tasks from different areas. For example, decision-making, knowledge representation, planning, training, natural language communication, and combining all of these abilities. And some philosophers and scientists could say that it includes consciousness, self-awareness, and wisdom. But we don't know where strong artificial intelligence will be present in our life. The achievements that lie at the basis of modern artificial intelligence technologies were obtained a long time ago, but had a number of shortcomings which are eventually solved. And deep learning and machine learning in general is driven by three technical forces. It's equipment, so it's computing power, CPUs, GPUs, and TPUs. TPUs stands for Tensor Process Unit. It's datasets. Obviously, it's big data we discussed before, and it's algorithms. For example, if you want to get from a point A to point B to a distant place where there are bad roads, rivers, and hills, then we can solve this problem by having a powerful all-terrain vehicle. This is our equipment. Also, we need a lot of good quality fuel In this context, this is data, big data, and the ways and plan to get over obstacles. It's our algorithms. And we go back for a minute. Again, three technical forces: equipment, computing power, datasets, and algorithms. Let's talk about machine learning. If we have labeled data, then we have questions or objects and answers or labels. We ask the algorithm to find the rules by which each question is associated with its answer. Imagine that you need to solve several problems in mathematics or physics in school. In this context, you can take the task and immediately see its answer in the book. I did this in school. And try to fit the task to the answer. If we perform this procedure many times for such tasks, we can learn to solve such problems. Then the algorithms got results. It compares it with the correct one, and we have the data with ready-made answers initially, if you remember, because it's labeled data. And it changes the model parameters to make the answer close to the correct one. This procedure is repeated many times until we reach the target level of accuracy. If we compare machine learning and traditional programming, then in programming, in the first stage we have data and rules, and we give instructions to computers to give results based on this. In machine learning, at the first stage we have data and results, and we ask machine to find the rules by which the data correspond with the answers. So we have training data, and we train the machine learning algorithm based on this data. We get some predictive model as a result. When using new data in this model, we expect that it will give the result we need. Types of machine learning tasks. There are several types of machine learning tasks: supervised, unsupervised, and reinforcement, as well as some other types. In supervised learning, we have labeled data. For example, it can be a set of images on which dogs and cats are highlighted. Supervised learning includes classification, regression, ranking algorithms, and some others. In unsupervised learning, we have unlabeled or raw data, and we ask the algorithm to find useful patterns in them. This includes clustering algorithm, dimensional reduction, association rules, etc. In reinforcement learning, we are dealing with the environment in which we place an agent and who receives positive and negative feedback and learns based on this. If you compare machine learning with a spaceship, then fuel is data, and the engine is an algorithm that runs only on fuel with the right quality and sufficient quantity, obviously. Here is an example of a classification problem where the algorithm distributes data into three classes. Previously, on the training data, the algorithm learns to understand why the data should fall into one or another class. This is an example of a classification task when applying for a loan to a bank. The bank analyzes your application and determines whether you can repay the loan or not. Here is an example of decision tree. It's a classification algorithm. It really looks like a tree with branches and leaves. Here you can see an example of the task of classifying emails with or without spam in email. Regression. In regression problems, we predict a numerical value, a number. An example of the linear regression is shown here. If we compare the problems of classification and regression with the student as example, then having a student profile with their grades and other parameters, we can classify them into one of the classes. For example, passed or failed the exam. This is so-called binary classification. We have two classes. This is why it's binary. If we want to predict the score or mark on the exam, it will be a regression task because it's number. Generally speaking, classification and regression tasks have a number of common features. A popular approach in unsupervised learning is clustering. We have unlabeled data and ask the algorithms to divide data into several clusters so that the elements in one cluster are similar to each other and differ from elements from other clusters. Here is a comparison of classification and clustering. Try to find the difference. Okay, let's go on. Another method is association rule mining. An example: if you analyze all your purchases in the supermarket, you can find popular combinations of goods that are taken together. This can be useful for marketing and proper placement of goods on these shelves to increase, for example, the average purchase receipt. Or reinforcement learning. It can be compared with trial and error method. Here some agent interacts with the environment, receiving feedback from it. This approach is used in unmanned vehicles, for example, in games where the algorithm learns to play and win the game. You can see an example on this slide. This example shows how the object learns to jump over a barrier. At first it jumps not enough high, but in the next steps it corrects its mistakes and solves the problem. On the right you can see the game Mario. An interesting case. The victory of the algorithms based on reinforcement learning over the champion of the game Go brought popularity to this method. Moreover, the algorithm then learned to win the game by playing with itself in virtual games. And it is worth noting that the reinforcement learning method is quite difficult to implement and is not often used in real tasks. Popular models in machine learning are linear models. We saw it when we discussed linear regression. It's random forest. It consists of several decision tree algorithms. It's gradient boosting, taking into account algorithmic achievements in building good models, and artificial neural networks, which are very popular now. An artificial neural network is shown here. History tells us that the researchers were inspired by the structure of neurons in the human brain, but that's where similarities end, and we still don't know much about the structure of the brain. We can imagine a neural network as a sequence of layers acting as a sieve, filtering the data passing through them, highlighting only the important parts and giving an output. Here we can see a neural network that has previously trained on labeled pictures of dog and cats. When we put a cat's picture on a neural network, it analyzes and gives the correct result. A neural network doesn't always give a 100% result, like all machine learning algorithms, but usually it works very well. Let's look at the several neural networks architectures. The first is convolutional neural networks. Convolutional neural networks are almost universally used in computer vision applications. Here we see the classification of objects in the image. The task of identification and segmentation of objects in the image. For example, in this picture, the neural networks correctly recognize the person, me, tie, book, chair, and some object on the door. Self-driving cars. Here's an example of detecting objects that a self-driving car sees. This is a simulation in a popular game, and we see cars, trucks, pedestrians. We can even estimate the distance to the objects in order to show a warning, if necessary, that we are at the dangerous distance with another car, for example. If we look inside the convolutional neural network, we will see that on the first layer it learns to recognize local patterns, selects arcs, for example, lines, etc. On subsequent layers it can recognize some signs, for example, eye, ear, if we work with faces. And on the output layer it can already see a specific object. But human is not perfect in object recognition as well as algorithms. Let's check it. Can we very quickly recognize where the fried chicken is and where the dog is? Funny example. Next one. Puppy or bagel? Next one. Dog or mop? Next one. Chihuahua or cake? Oh, it's a very good one. Next one. Or we can see the same object in different ways. For example, a glass is shown here, but someone can see the oil flowing down. Another example. The neural network was trained to recognize emotions on the face. Another popular architecture is recurrent neural networks. Recurrent neural networks have an architecture that takes into account the peculiarities of the sequence, for example, text data or time series. It works with text, and applications for recurrent neural networks include the following: text analysis, information retrieval, information search, text sentiment analysis, question and answer system, including chatbots, for example, and also it's text generation, machine translation, automatical abstract, annotate or simplify text, etc. And neural networks can be used to generate images, text or music, and there is also a special section or field. It's generative machine learning. Here's an example of mixing style images. You can show one image in the style of another image. Some applications that are built in, for example on Instagram or Snapchat, works on similar principle. Generative adversarial networks are capable of generating realistic images. This example shows a popular example which shows that there is a man with glasses. Subtract a man without glasses from it. This is actually image of another man. And add a photo of a woman. So what we get? We get a woman with glasses. Oh, magic! You can teach a neural network to open a person's eyes, for example, if he or she accidentally blinks when making a photo. Or another interesting example, generation of image of people who do not really exist. Can you believe it? Here we see a very realistic photo. And there is a site, thispersondoesn'texist.com, that shows generated photos of people who do not really exist. After each page refresh, we see a new picture, and in the lower right corner you can see link to sources. And there is a similar projects, for example, this website, thisartworkdoesn'texist.com, show us artwork generated by a neural network. Another one, funny one, thiscatdoesn'texist.com. When you refresh a page, you will see new picture of a cat. This one, thisHorseDoesn'tExist.com. It's a weird horse you see here. Oh, chemicals. ThisChemicalDoesn'tExist.com. Another good example. ThisArticleDoesn'tExist.com. World news article AI written. It's also a problem of a fake news, as you probably heard about that. Or else, oh, thispersondoesn'texist.com/friends, you can see AI generated dialogues for friends. Oh, AI generated scene. Looks amazing. Another interesting service. Here they suggest guessing where is the real person and where is the generated one. Can you guess? I think generated one is on the right. Yes. The man on the left pictures is real one. Oh, fully neural network, another interesting topic. Weaknesses of neural networks are often used to mislead them. For example, you can add a little so-called noise in the image of a kitten so that it becomes recognizable as a computer. Oh, it's funny and weird. Or in the picture on the right, we see a strange toy next to banana, which forces the neural network to recognize it as a toaster. How can it be true? But what about us? Again, back to the mistakes that people can make when recognizing objects in the image. What do you think is shown in this picture? I personally see a dog here. But what about you? It's actually a Siamese cat. Siamese cat. With a change of a few pixels in the image. And this has already allowed to mislead a human who saw a dog in the pictures. Really. Oh, another interesting example from Instagram. How do you think? Is it dog or cat? By the way, remember a few years ago there was an interesting riddle on the determining the color of a dress. I still see a white and gold dress. What about you? I know that I'm not right. It's not gold and white. But anyway. Oh, a neural network can animate static pictures. So we can see the facial expression and movement of even a non-existent person, especially if you see on the picture on the right. Neural network can also generate pictures, of course. For example, a painting by AI was sold for almost $500,000 at Christie's auction in New York on October 25th, 2018. Wow. A neural network can generate text, poems, a script of the film, and we have already seen an example with the generation of dialogues for the series Friends, as you probably remember. It can generate a description of what is shown on the pictures or video. The music industry is increasingly influenced by neural networks. already Facebook is developing artificial intelligence that can recreate music of a particular genre and transform a composition from one genre to another. And a neural network can take a recording of a work, for example, by Bach, performed by a symphony orchestra, and turn it into a symphony with Beethoven's piano part. And the quality of compositions is not the best yet. However, most listeners, as a rule, including me, can determine which melody is real and which is AI made. And artificial intelligence is actively penetrating our lives, and large technology companies play a huge role in the development of AI technologies. There is a need to establish some rules for artificial intelligence. For example, Microsoft CEO Satya Nadella offers the following rules. 1. AI must be built to aid humanity and preserve our autonomy. 2. AI must reflect transparency, or humans must be aware of how the technology works. 3. AI must enhance efficiencies without destroying the dignity of people. 4. AI must be designed to address the need for intelligent privacy. 5. AI must reflect algorithmic accountability. Humans can undo unintended harm leveraging algorithmic accountability. And 6. AI must prevent bias. And there are also 4 more rules, and you can see them on the link below. Synergy of human and AI. If we are talking about this, then we should do this in the paradigm of AI plus human instead of AI or human. That is, AI will help a person perform various operations, potentially increasing efficiency and capabilities. And final pictures. There is a service that evaluates the chance that the image is awesome, and we will see how strongly the data on which the algorithms was trained affect the result. I uploaded my photo to estimate my awesome rate, and I got 0%. But the service correctly estimated what is shown in the pictures and suggested some tags. For example, man, business, office, sitting, adult, male, indoor, desk, document, manager, etc. So, then I uploaded the pictures of the generated woman that we saw earlier. Again, 0% and also correct text. One person, beauty, woman, female, one woman only, etc. So what next? What could be more attractive? Maybe beautiful food? Now we have got 2.2%. What kind of picture can I choose for that? Maybe I'll try a cat? What do you think? Cat? Oh, almost 60%. But it's not so much. What else? Maybe I should try a dog? Wow! Dog, almost 90%. What conclusion can we draw? The system was trained on data in which cats and dogs were marked as more attractive. This is my guess. Therefore, do not forget that much depends on the data on which artificial intelligence was trained. And this data will also have all the deviations, nuances, completeness, and some bias. It's very important. In any case, we will have an interesting future. Thank you very much.